Hello everyone, I am Subhash Aram from Mechanical Engineering Department. Today I am going to explain about the Brayton cycle with regeneration, intercooling and reheating. What is a Brayton cycle? The Brayton cycle is a thermodynamic cycle that describes how gas turbines operate, involving compression, heat addition, expansion and heat rejection. It works on constant pressure process and is widely used in jet engines and power plants. Key components of a Brayton cycle. First one, compressor. It takes a It takes in ambient air and compresses it to higher pressure and temperature. It increases the air's density and prepares it for efficient combustion. The compressor consumes part of the turbine's output power. Second one, combustion chamber. Compressed air enters the combustion chamber where fuel is injected and ignited. The combustion process raises the temperature of the air significantly. This high energy gas then flows to the turbine. How gases expand through the turbine, causing it to rotate the rotate and produce mechanical work. This work is used to drive the compressor and any external load. It is a major power producing component of the cycle. Function of the turbine. It expands the high temperatures gases to generate mechanical work. This work drives the compressor and produces useful power output. Heat exchanger or regenerator. It captures waste heat from the turbine exhaust and transfers it to the compressed air before combustion. This reduces the fuel required for heating. Regeneration improves the cycle's thermal efficiency. Exhaust or outlet. After expansion, the low pressure gases are released through the exhaust. In open cycles, they are discharged into the environment. In closed cycle, they are cooled and recirculated. Types of Brayton cycle. Simple Brayton cycle, regenerative Brayton cycle, intercooled Brayton cycle, reheated Brayton cycle, advanced Brayton cycle. Simple Brayton cycle. Working principle of simple Brayton cycle. The simple Brayton cycle is a thermodynamic cycle that describes the working of a constant pressure heat engine primarily used in a gas turbines. It consists of four ideal processes: ideal compression, constant pressure heat addition, isentropic expansion, and constant pressure heat rejection. A real life example for the simple Brayton cycle. A real life example of the simple Brayton cycle is a jet engine used in commercial aircrafts. Air is compressed, mixed with fuel, combusted, and then expanded through a turbine to produce thrust. This cycle efficiently powers aircraft like Boeing and Airbus jets. Regenerative Brayton cycle. Working principle. The regenerative Brayton cycle works on the same basic principle as the simple cycle but includes a regenerator or heat exchanger to improve thermal efficiency. After the air is compressed instead of directly entering the combustion chamber. Examples for a regenerative Brayton cycle. A real life example for the regenerative Brayton cycle is found in industrial gas turbine power plants used for electricity generation. These turbines used regenerators to recover waste heat and improve fuel efficiency. Third one, intercooled Brayton cycle. Working principle. The intercooled Brayton cycle improves efficiency by reducing the work required for compression. In this cycle, the compression process is divided into two or more stages. After the first stage of compression, the air is passed through an intercooler where it is cooled at constant pressure before entering the next stage of compression. A real life example of the intercooled Brayton cycle is found in derivative gas turbines used in naval ships and aircraft propulsion. These turbines are used intercooling to reduce compressor work and improve performance. It's especially useful in application requiring high power to weight ratio. Fourth one, reheated Brayton cycle. In this cycle, the high pressure gas expands partially in the first turbine and is then reheated in a second combustion chamber. The reheated gas expands again in the second turbine stage, producing extra work. This process increases the total power output and improves efficiency. Reheated Brayton cycle are used in large industrial and military gas turbines, such as those in power generation plants and naval ships. The reheating process helps extract more energy from the hot gases. This is especially used in heavy duty turbines like the GE frame series used in power stations. Fifth one, advanced Brayton cycle. The advanced Brayton cycle combines intercooling, reheating, and regeneration of maximize efficiency and power output. Intercooling reduces compressor work, regeneration recovers waste heat, and reheating increases turbine work. This integrated approach enhances thermal performance and fuel economy.